Then for LCM, you're looking for the highest grouping of each factor and you write it down. Then the last one, the LCM of 34, 51, 68, and 102. The highest common factor there is 17, and the LCM is 204. Are there any questions on prime factorization, HCF, and LCM? All right, for LCM, I'll explain again. If we look at our numbers, 34 is 2 and 17, 51 is 3 and 17, 68 is 2, 2 and 17, 102 is 2, 3 and 17. So for LCM, you look at the factors that exist already. For these factors, you see, okay, we have a 2. If you look at the 68, that's where we find the highest group of 2s. So you write both of those down. Then you move on to your next factor, the 3. If you look at the 3 and 51, the 3 in 102, it's just one occurrence. There is no larger group than 1. So it means 1 3 will suffice to represent those 3s there. Then we move on to 17. We see that 17 only appears once in each of those numbers, so we also write it down once. Then you multiply everything out together, 2, 2, 3, and 17, and you get your 204. So what you're trying to make sure is the highest group of each of the prime factors is represented. It is written down, and you multiply it out. All right. Those who are asking me to re-explain LCM, are we together now? Yes, Nibble, you lose marks if you just write down the answer, because usually the questions have part marks. So at most on a generous day, you'll get 1 mark for the answer and you lose about 4 marks for the working. So working is very important. Write down your working. All right, so that's about it for HCF and LCM. We'll now move on to the next thing. Powers and roots. So for the next hour or so, we'll be concentrating on applications of the rules of powers, or also evaluate roots. Right, if you see that term there on my slide, 5A3. 5A3 is a term that has a combination of a coefficient, that's your 5. A is called the base, and that 3 is called the power, or it's called the index, or the exponent. When we have more than one index, they are then called indices. So that's why you see in some textbooks or in some articles, you see it written as rules of indices, because there's more than one index. Basically, when we are raising a number to a certain power, what you're doing there is just repeated multiplication, as simple as that. 2 to the power of 3 means you're multiplying 2, 2, and 2 to give you an 8. And in that term, the 5A to the power of 3, it means you're multiplying the coefficient 5, then some unknown A, that unknown again, and that unknown again. So 5 and 3 A's. Sometimes you'll be asked to change an integer into some base and its power. So for example, we have 16 multiplying 8, and you have to express it as a base of 2 to some power 8. If we break down 16, we'll see that 16 is equal to 2, 2, 2, and 2. We see that that prime factorization is now coming in very handy there. Then if we look at the 8, same thing, 2, 2, and 2. When we multiply that out, which means we are now combining those 4 2's from the 16 and the 3 2's from the 8, it is the same as if you have just added the powers. That, again, is already showing us some of the rules that work. But you see that this only works if the base is the same. The base there being 2. You can add the powers if the base is the same. So in other words, we can express 16 times 8, still the same as 2 to the power of 7, where 2 is your base and 7 is your power. What are the rules? I need you to write those rules down, and you should keep them somewhere in your brain's hard drive, because you will not be getting them in any formula booklet. You should know them by heart. Write them down, because for any other example we'll be looking at today, you will still need to refer to this. So we look at rule number 1. Same base, the base there is B. So multiplying numbers of the same base is the same as adding their powers. That's where the B to the power of m plus n is coming from. Then if you look at rule number 2, dividing numbers of the same base is the same as subtracting their powers, or finding the difference on their powers. In this case, m minus n. Rule number 3 is raising a power to another power. It's the same as just multiplying out. We already know what brackets stand for. It's the same as multiplying out. Rule number 4, anything to the power of 0 is equal to 1. 1 million to the power of 0 is 1. 10 trillion to the power of 0 is equal to 1. So anything that has the power of 0 is equal to 1. Then we have rule number 5. B to the power of a negative m is the same as changing it to a fraction, which is 1 over b to the power of m. And then we have a little note there that says a negative power denotes a reciprocal. I'll find out from you in the test on Friday what a reciprocal is. Test on Friday. Hint, hint. Rule number 6. B to the power of 1 over m is the same as finding the m root of b. So m can take any value from 2, 3, any integer value going up. You can find the cube root, you can find the 5th root, you can find the square root. So in other words, you're finding the root. Then rule number 7 is a combination of rule number 6 and rule number 3. So you first find the root, and whatever answer you get, you then raise it to the power of m, which is the same as finding the nth root of b to the power of m. I'll give you just 2 minutes to write those down. Write those down because you will need to refer to them a lot today. 2 minutes, and then we move on to the examples. Right, I need you to work number 1 to 7. For each of the questions, I need you to state which rule you have used, and then you give me the answer. For that, I'll give you 5 minutes because these are very simple. 5 minutes. State which rule you have used and give the answer. Nicole, what's your answer for the first part? Number 1, x squared times x cubed. What's your answer? X to the power of 5. All right, thank you. Yes, Ngesimane. Number 2, what's your answer?
Ma'am, you can just use Louis. You don't have to use that long name.
All right, Louis.
I used the rule 2, and the answer is x to the power 3.
X to the power of 3, yes, thank you. Viwe, you still owe me.
Yes, ma'am.
Number 3.
Number 3.
Yes, 3.
X to the power 6.
Which rule was that?
Rule number 3.
Rule number 3, thank you. Tebo Komampuru, welcome. Give us the answer to number 4. Tebo.
I'm sorry, ma'am. I joined a bit late, so I missed the part of the rules and whatnot. Like, I just joined it now.
Is it? You still owe me. All right, Andy. Hi, give us the answer to number 4. Andy. Andy O, can you hear me? Lebogang, do you have an answer for me? Number 4. Lebogang. To me, you can give us the answer?
Hi, ma'am, can you hear me?
Yes, I can. Number 4?
Number 4 is 0, ma'am. I used rule number 4.
And what's your answer?
0. No, 1, sorry.
1. Anything to the power of 0 is equal to 1. All right?
1.
Thank you. Eric, number 5.
Hi, ma'am. Number 5, the answer for it is 7 over half.
7 over half. Which rule is that?
That is rule number 5.
Rule number 5. It changes it into a fraction, so it becomes 7 over half.
Like over the power, like, yeah, the half is a power. It's 1 over 2.
Look at that rule again. Look at that rule again.
Because I see there's a negative sign, but then when it comes over to the other side, it does not have the negative sign. It says B 1 over M.
Yes. So when that 2 goes to the denominator, it becomes positive. So it's the same as 1 over 7 squared. It changes it to a fraction. Can you see that?
Fraction. 1
Yes,
over
that's 1 over b to the power of m. That's a fraction.
Oh, okay.
Yes.
Okay.
Your 7 is the b, your m is 2.
All right. 7 is the B, and the M is 2.
Mm-hmm. Right, so Mduduzi has already given us the answer. Thank you. Yes, it is 1 over 49. Joshua, number 6.
Number 6. It's I think it's 3 square roots. Okay, I can't say it. It's the 3, and then the square root, and underneath it, it's 125.
So it's a cube root of 125. Yes.
Yes, man.
And the answer is, what is the cube root of 125? You can evaluate
5.
that. It's equal to?
5. Wait,
Yes, it is equal to 5. Yes, thank you.
Okay.
Lawrence, afternoon, number 7. Lawrence? Lawrence? Tiani, can you give us the answer?
For question 7,
Question 7, yes.
cubed root 125 squared, or to the power of 2. And then I simplified it further. The answer is 25.
The answer is 25. All right. Thank you very much. Okay, so that was just us getting our feet wet, but be rest assured that in a test, we will never, ever give you such simple questions. You'll be getting a combination of 1 or 2 of the rules going on like that. All right. So just verify your answers for those who could not hear clearly or had network issues. Those were the expected answers. 2 plus 3 is 5. 7 minus 4 is 3. 2 times 3 is 6. Anything to the power of 0 is 1. 7 minus to the power of minus 2 is the same as 1 over 49. The cube root of 125 is 5. The cube root of 125 squared is 25. All right. Please make sure that those rules are at your fingertips and you are able to recall and apply them. Tsudu, there was no equation. You were just squaring 125 and finding the cube root of that. So you find the cube root of 125 squared. Or you could, or how do we write it out? All right, I will fill that in the slide for you. All right. We'll look at an example just now that shows the square and the cube root. All right, I'll do that for you. All right, then we have roots. We've already established from rule number 6 that anything that has a fractional power is actually a root. It could be a square root, a cube root, a 4th root, 10th root. It can be anything. So that small number there in the radical sign shows you what root it should be. A few rules to remember concerning roots. For example, if you look at odd roots, an odd root means the number is odd. For example, your 3, your 5. What are odd numbers? Numbers, when divided by 2, give you a remainder of 1. All right, so odd roots are unique in the real number system. In other words, we only have one value when you find the odd root. Louis, I will give you questions. They're coming up, don't worry. Real challenging ones. Be patient. I'll get back to you just now. All right, an example there is if you have 6 to the power of 1 over 5, where the odd root there is 5, you see that you get a unique value to 3 decimal places, 1.431. Odd roots of negative numbers are also negative. For example, if you find the 5th root of negative 32, you also get an answer that is negative, which is -2. Then we have even roots. Even roots, on the other hand, do not have unique real numbers like the odd roots do. What do we mean by that? It means that there is a possibility of 2 answers when it comes to even roots. For example, the square root of 4 can either be a +2 or a -2. So odd roots are unique, then even roots are not unique because you can get a positive and a negative. A +2 times a +2 gives you 4. A -2 times a -2 also gives you a 4. All right, let's quickly look at those, the next set of questions. All right, those are our expected answers. For the first one, you just add the powers. 8 plus 2 is 10, so it's the same as 5 to the power of 10. Part B, 4 minus 6 is minus 2, so it's the same as 6 to the power of minus 2. Then part C, you're multiplying out 4 and 3, that gives you 12, so the answer is 7 to the power of 12. Then part D, anything to the power of 0 is, 19 to the power of 0 is the answer. Then number 2, our roots. 16 to the power of 1/4 is the same as finding the 4th root of 16. And because this is an even root, it means it can be plus or minus. Then the cube root of 3 to 3 decimal places is 1.732. Then the last one is minus 2.000. Any questions on those very, very easy things? I'm assuming there are no questions. Right, the next part, ma'am, can you write out B and C? What do you mean write out B and C, Tsulu? Wait, let me just unmute you. Sulu, what do you mean I should write it out?
Oh, okay. Ma'am, because on number B, when I wrote it out, I said 3 to the power of 1/3. And it seems like it was incorrect. So what was I supposed to actually write in order to get that answer instead of just putting it in the calculator?
Oh, okay. If you look at the illustration of 2A, can you see what 2A looks like?
Mm-hmm.
So where you have that 4, that's where you're going to write your little 3.
Okay.
And where you have your 16, that's where you write the big 3.
Oh.
Yes.
Okay.
So
Oh,
the
no,
root,
ma'am, isn't it the same thing then
the same thing as?
as the question itself?
No, it's asking for the cube root. It's not a square root. It's not a 4th root. It's the cube root.
So that question you just put it inside the calculator.
Yes, basically, and it's asking for that in 2, 3 decimal places. Yes.
Okay, thank you.
All right. Shalom, you have a question. What part of B don't you understand?
Ma'am, I also got 1,442. So I did exactly as she said she did too, the 3/1 or 1/3. But now, as you explained, I kind of getting there. But I'm still a bit lost how you got the 1.732.
All right, let me just verify something. Kimi is also getting 1.442. All right. All right, it looks like we're having a lot of problems with the use of calculators. Depending on the calculator that you're using. Now I can't go through the explanations for each calculator. But if you look at the illustration there from question 2b, where you have the little 3, in question C, you'll be putting a little 5 there. And where you have a 3, the big 3, you're putting -8. So the 5th root of -8. To check whether what you're doing is correct, whatever answer you give me, if you not square it, if you find the power of 5 of that, it should still give you -8. If it's not, then that's not the right answer. In other words, you need to work with the reciprocal of that. Please just get acquainted with your calculators. Remember, calculators really obey what you are telling them. If you put that 1/5 in the wrong place, it'll give you the wrong answer. It's 5th root of -8 and also 3rd root of 3, cube root of 3. All right, for those who don't have questions, you can move on to numbers 1 to 5. Those who still have problems with the previous exercise, you can write in the chat and we'll help you from there. So those who don't have problems, you can move on with those questions 1 to 5. Now you'll be using a combination of rules to find the simplified answer. Remember, the rules of indices only work if the base is the same. So if you're working with a base of x, then it would work for another base of x, not x and 1. All right, same base, that's where it works. Those still facing problems, let's deal with it in the chat.
table.
They are blurry. Yeah.
And you can take it from
Okay, cool. Do this. Just a minute. Okay. I'll contact Shamin now.
Right, guys, I'm trying to reload it. Don't worry, I'm trying to reload it. All right, I hope the screen is visible now. This exercise is going to take us all the way to break time. So we'll come back at 3:15 with answers. Those who still need help will attend to in the chats, but if you don't need help and you need to work offline, it's up to you. You can come back at 3:15 if you want to save data. right, guys. Let me know in the chat how the exercise is going. Those are some of your typical test and exam questions that you get, a combination of rules to use. I'll give you a few more minutes and then we will look at the solutions. Oh, good, Eric, you're done. Right, let's look at the first one. Simplify the following: x squared y to the power of 5 divided by x y to the power of 4. I'm looking for at least 10 correct answers in the chat box. 10 answers, okay, not correct answers, 10 answers in the chat box before I reveal the working. Put your answers in the chat box. Right, Heinz says XY, everybody else XY. 1, 2, 3, 4, 5. Okay. All right. Looks like we have that one in the bag. All right, let's just verify for those who didn't get it. All right, first you're going to subtract 1 from 2 because division is the same as subtracting powers. Then you do the same for your base of y, 5 minus 4, and in both instances it's equal to 1. So the key thing to remember there was the base should be the same. All right, so our answer there is xy, correct. All right, number 2. Answers to number 2, xy to the power of 3. All right, that's Eric. What else are people getting? Number 2. Eric, is xy power of 3 for number 2? Type out your answers to number 2. Right, Mdudu says x to the power of 12 over 64 to the power of 64y to the power of 9. Same as Shalom. Zulu, x to the power of 12. 4y to the power of 9. Emily says x to the 12 times y to the power of negative 9. All right. Looks like there is some consensus. X to the power of 12 over 64y power of negative 9. Right, interesting. All right, let's verify. Okay, because everything is in the bracket to the power of 3, it means each of the terms in the bracket will be raised to the power of 3. So 1 over 4 to the power of 3, x 4 times 3, y to the power of negative 3 times 3. You simplify that and you get x to the power of 12 over 64y to the power of 9. You can leave your answer as 1 over 64x to the power of 12y to the power of negative 9. So either that second last stage or the last stage, either way. But if the question specifies that leave your answer as positive roots, then the last one, x12 divided by 64y to the power of 9 is the final answer. So pay attention to all the instructions. In this case, it just said simplify. So you could leave it as a negative power, or you could go all the way and make everything positive. Right, Louis, you say you're lost. Which part?
Yeah, everything confuses me. I won't lie to you, ma'am. Yo.
Did you write down the rules?
Yes, I did.
Okay. All right, I'll try and break down the question again. All right, let me read through it.
Yo. No ways, yo.
All right, so if you look at the question, you see that it has a few parts to it. Don't try and do too many things at once. Try and work it out one at a time. Right, so we have in the numerator 4x to the power of 5y. Numerator is 16x y to the power of 4. And all that is in the bracket. The position of the brackets is very important. All that in the bracket is being cubed. So it means it's multiplying itself 3 times that bracket. So you try and simplify what is in the bracket first. We have your usual natural numbers, 4 and 16. You can simplify that. 4 divided by 16 is 1 over 4. Then you're going to apply rule number 2 to evaluate your x's. X to the power of 5 divided by x is the same as x to the power of 5 minus 1. You do the same base, y to the power of 1 minus 4. We are subtracting because this is division from rule number 2. So you evaluate that bracket first, and you're going to have 1/4 x to the power of 4, y to the power of minus 3. This is still inside the bracket. We have not dealt with that power of 3 that is outside. Then when you have evaluated that bracket, the next part is now to deal with the things inside the bracket one at a time. So each of the terms in the bracket is going to be raised to the power of 3. Always pay attention to the positioning of the brackets. Whatever is in brackets, it means it is subject to that power of 3. So when you break it down, it's the same as 1/4 to the power of 3, x to the power of 4 to the power of 3, y to the power of minus 3 to the power of 3. Then you can now simplify using rule number 3. X to the power of 4 times 3, it means you're just multiplying out the powers. That's where the 12 is coming from, x to the power of 12. Then for y, minus 3 times 3 is minus 9. And your 1/4 to the power of 3, it means 1/4 times 1/4 times 1/4 is the same as 1 over 64. Then if you want to deal with the negative powers, it means it's the same as x squared, so not x squared, x to the power of 12 in your numerator, and your denominator is 64y to the power of 9. The negative power there makes it a fraction, so it becomes part of your denominator. Practice makes perfect. So just whatever you do, just write down on the side of your working which rule you are using and why, so that at least you can follow what's going on and you remember. All right, Louis, let me know in the chat if you are okay now. Right, then for number 3, this is multiplication. So f to the power of minus 3 times f squared times another f to the minus 3. You're simply going to be adding your powers. Minus 3 plus 2 plus minus 3. Remember, a plus and the negative, the overall sign there is negative, and the overall power there will be minus 4. You can change that minus 4 so that it's a positive term throughout. It's the same as 1 over f to the power of 4. Right, so our answer there is 1 over f to the power of 4. Right, as correctly pointed out by Mduduzi, yes. And the next one, number 4. If I answer, anyone who doesn't understand how we got to that answer in number 4? Okay, I'll explain. If you look at what is in the bracket, we have a coefficient 2, we have the term x to the power of 3, we have the term y to the power of minus 3. And because everything is in the bracket to the power of that negative 2 outside, it means each term is also going to be raised to that negative power of 2. That's the way you remove the brackets there. Anything in the brackets to the power of something, to remove the brackets, that something should raise each of the terms in the bracket. So we have 2 to the power of negative 2, then x 3 to the power of negative 2, then 1 to the power of negative 3, again, times negative 2. Then using your rule number 3, 3 times minus 2 becomes minus 6. Then for the y, minus 3 times minus 2 becomes a positive 6. 2 to the power of minus 2 is the same as 1 over 2 squared, which is a quarter. If the question is asking for positive powers, then if it's asking for positive powers, then your answer will be y to the power of 6 divided by 4x to the power of 6. If it's not asking for that, then it's not necessary to make x to the power of minus 6 positive. Only if the question further asks you to leave the powers as positive, that's when you can continue. Either way, both of those stages are right. So the key there to remember is whatever is in the bracket should be raised to the power that is outside that bracket. As long as it's inside, remember that power affects it. Oh, number 5 looks very interesting. What are your answers to 5? Right, Heinz says 9b squared times c to the power 14 over 4a squared. Sulu says it's minus 2a to the power of 6 over b to the power of 2 times c to the negative 14. 2 to z, 9 to the power of 4. 2 to z, that's not complete because I can still see an a and b in your denominator. So it means you can further simplify that. Eric, 9 over 4, a to the power of negative 2, b to the power of 2, c to the power of 14, all right? Lawrence, you've not typed anything today or said anything. Type out your answer. What did you get? Lawrence. Neville, type your answer. Right, let's verify. Right, we first deal with what is inside the bracket. Right, so for a, our base of a, we have a to the power of 3 dividing a squared. So a 3 minus 2, that becomes a. We do the same for b. B to the power of 2 minus 3, because it's division, it means we find the difference of our powers. Then for c, it is 0 minus 7. Overall, there is minus 7. And because everything is still in the bracket raised to the power of minus 2, we still have to deal with that negative 2. Then you are going to raise each term in that bracket there to the power of negative 2. So minus 2 over 3 to the power of negative 2, a to the power of negative 2, b to the power of negative 2, c also to the power of negative 2. I'll go through that again. Simplify the bracket first. The a's on their own because it's the same base. A3 divided by a squared is the same as a to the power of 3 minus 2. B squared minus 3 because it's division. C to the power of 0 minus 7 because it's also division. Then you're going to raise each term in the bracket to the power of negative 2 because that negative 2 is affecting each term in the bracket. All right, so when we raise each term to the power of negative 2, minus 2 over 3 to the power of negative 2 is the same as 1 over negative 2 over 3 squared. So to remove that negative, I'm just changing it to a fraction. Then a1 times minus 2 is minus 2. B times the negative 1 times negative 2 becomes positive. Minus 7 times minus 2 becomes a positive 14. Then if you want to have positive roots only, the negatives go to the denominator, which means your answer will be 9b squared c to the power of 14 over 4a squared. I'll go through this example again. Deal with the bracket first. Simplify your bases. The different bases here are A, B, and C. Then your overall powers will be A to the power of 1, B to the power of -1, C to the power of -7. All that is being raised to the power of -2. At this stage, you can also change this to a fraction, which will be 1 over everything in the bracket squared, if you don't want to deal with the negative power. Then whatever power we have outside the brackets, you are going to raise each term inside the bracket to that power. -2 over 3 to the power of -2 is the same as the fraction 1 over -2 over 3 squared. Simplify that new denominator. A to the power of 1 times -2 gives you -2. B times -1 times -2 gives you a +2. C to the power of -7 times -2 gives you the +14. And if you require the answers to be all positive powers, then that A -2 goes to the denominator to become A squared. All right. Is that making sense? To me, you have a question? Read to me,
Ma'am, did you put me on speaker? Yes, ma'am.
the network
So
is kind of.
when we're dealing with a question like question 5, ma'am, we deal with the exponents normally, and then just put the coefficients as a fraction in order
Yes.
to better deal with the.
Yeah, so in this case, it means you deal with coefficients on their own, the base of A on its own, base of B on its own, base of C on its own. Yes.
All right,
And
thank
you
you.
apply your rules 1 to 7. All right, looks like we are in agreement and everything is going smoothly. Let's kick it up a notch. If you go to MS Teams and class assessments, in the class assessments, class material, under assessments in the exercises folder, there is an exercise there written exercise powers. Open that PDF. There are about 12 questions. Start working on those questions. Go to MS Teams. Under the class materials folder, in the assessments folder, 2.1 exercises, the one written exercise roots, that one. For those who couldn't see that other blurry exercise, I've also pasted it in this exercise folder, the one written blurry exercise. Right, let's work on the exercise of roots. Sorry, Louis, yes, you said you have a question?
Ma'am, so for that fraction there, you just times them both by each other and then you just swap them around to make them positive.
Yes, so we have minus 2 over 3 in brackets
Yeah.
to the power of
Yeah.
minus 2. So to
Yes.
make it positive, you're going to change it to 1 over, still in brackets, minus 2 over 3 squared. Then it means your
Okay.
denominator now is minus 2 over 3 squared.
Okay.
Squared means times and times, so it means it's
Yeah.
the same as 1 over 4 over 9.
Okay.
And then that is the same as actually just flipping it to 9 over 4. From
So
yesterday's,
so basically, like in easier way, like I would times 2 by itself, which would give me 4 times 3 by itself. Oh, I'm so confused now.
yes, squared means it's just negative 2 over 3 times negative 2 over 3, yes.
Okay. Now I
And
get you.
all right. And remember,
So-
1 over 4 over 9 is the same as
Yeah.
1 divided by 4 over 9. And yesterday we said division of fraction is the same as inverting it. That's how it becomes 9 over 4.
Okay.
All right.
Thank you, ma'am.
All right. Lebogang, I'm going to give you, let's say what, 15 minutes to answer the first 5. Then we come back and we get the answers for the first 5 and we alternate like that. All right. So at 4:10, I'll be giving you the answer, or no, you will be giving me the answers to A to E. Right, in the chat box, what is the answer to 1a? 8 to the power 6 times 8 to the power 5. What answers do you have? Eight to the power of 11. Yes, Nebo, Eric, I am there. That's correct. So we're simply adding our powers there, 6 plus 5, which gives us 11. Right.